Alright, so this is going to be a video on reviewing the properties of rigid transformations and congruence. So it's going to cover pretty much the previous videos I made for the geometry, the new geometry that we're doing for this next unit 2. Alright, so let's go ahead and review the videos that I've done so far and pretty much just get a general idea of what's going on here. So the first one here says, well, first things first, it says reviewing properties of rigid transformations and congruence. Okay, so let's look at rigid transformations first. All right, let's review the rigid transformations first. It says length of lines does not change. Okay, we know that. We know that when we rotate, translate, or reflect, the length of lines does not change. We also know that if you rotate, translate, or reflect, the measure of the angles does not change. All right, let's look at this example real quick. So here we have the triangle. Here we have triangle A. All right, triangle A has length. Triangle A has length. Let's see. Let's measure it. Okay, so let's say this longer side. It's called the hypotenuse. Let's say this side is 4 inches. Okay. This side right here, the side from 90 degrees to 60 degrees is about a little under 3 inches. Okay, and this side is about a little under 3 inches also. All right, so let's see what happens to those sides if I rotate this. Okay, well, nothing happened, right? This side's still 4 inches. Okay, this side and this side is still about 3 inches. All right, if I rotate it again, does the length change? No. If I rotate it again, does the length change? No. What if I translate it? What if I slide it? Did this length change? No. Did the length change here when I slid over here? No. All right, is this length changing? No. Okay, so that's pretty much length of lines not changing. That's what that means. Okay, so if we rotate 90 degrees, the length does not change for any of these. Okay, rotate again. This length, and this length is still the same. All right, same thing with reflections. Okay, let's say we reflect this over the y-axis. Let's do a reflection over the y. Now we're here. Did the length change on any of these sides? No. Okay, it's still the same piece of paper. We're not making it bigger or smaller. Okay, the length is the same. All right. What if I reflect it over the x-axis? This is a reflection over the x-axis from where it is now, like this. Okay, so this is a reflection over the x. Okay, is the length changing when I do that? No. Okay, let's look at this next one. The next one that we looked at says the measure of angles does not change. Okay, so let's look at that. So as you can see here, this measure of this angle is 90 degrees. Okay, it's a right angle. That's why it has the little square in the corner. Okay, because it's 90 degrees. This one's 60 degrees, and this one's 30 degrees. All right, it's just upside down. Okay, this one's 30 degrees. All right, so we have triangle A here. Let's see what happens to the measure of each of these angles when I slide it down. Okay, notice nothing happened. Okay, because it's a rigid transformation and the measure of angles does not change. Okay, the 90 degrees is still 90 degrees. 60 degrees is still 60 degrees. Same thing with the 30. All right, what if I translate left? Okay, still nothing. All right, so we know translation doesn't do anything. What if I'm starting right here and I rotate this triangle 90 degrees clockwise? So clockwise, like a hands on a clock, go like this. Okay, did any of the angles here change? No. The one that was 30 is still 30. The one that was 90 is still 90. The one that was 60, still 60. Okay, so that's for rotations. What if I rotated 180 degrees counterclockwise from where I am? So counterclockwise. So here's 90 degrees counterclockwise. Here's 90 degrees. So we need one more 90 to make 180. There's 180 degrees counterclockwise. Okay? Did any of the angles change? No, that's 90. Okay, it's still 90. That one's still 30, and that one's still 60. Okay, it's the same piece of paper. We're not changing the piece of paper. All right. So let's look at the reflection now. Okay. So let's see what happens when we reflect over the y-axis to the measure of the angles. Well, this one's 30 degrees, 90 degrees, 60 degrees. If I reflect it over the y-axis, still 30 degrees, still 90 degrees, still 60 degrees. Okay, the measure of the angles does not change if you do any of these three. All right, guys, that's pretty much all it meant for rigid transformations. Not changing the length of the lines and not changing the measure of the angles. Okay, so let's go look at this congruence now. Congruence for two figures. Two figures are congruent if one of the figures can be placed directly or exactly on top of the other using rigid transformations or rigid motions. Okay, remember rotation, translation, reflections. Okay, so let's look at this triangle. All right, so what this is saying is that these two triangles are the exact same triangles if I can rotate, translate, or reflect this one, and then when I do that, I get this triangle to be exactly on top of this one. Okay, let's see if I can do that with these triangles. Let's see if I can make any mixture. I can do whatever I want with these. It doesn't matter the order. Okay, it does not matter the order. It doesn't matter if translations first or rotations first. Okay, as long as you're only doing these three, and you can get from this one to this one, they're congruent. Okay, so let's see what that means. All right, so we want to check, is triangle A congruent to triangle B? Let's find out. All right, let's see if we can do any of these three to get here. Okay, first let's see. If I'm looking at this right now, I think maybe I would, I don't know, maybe we'll just try stuff. Let's try to translate to the right. Okay, so I translated to the right and now I'm here. Okay, what could I do here to get this 60 degrees to be on top, this 30 degrees to be down here, and this 90 degrees to be down here? Well, I could reflect over the x-axis like this. Oh, and there you go. That's it, they're congruent. Because look, here's 60, there's 60, there's 90, there's 90, there's 30 and 30, and they're exactly on top of each other when I do that. So that means they're congruent. Okay? Maybe we'll try a different way. Maybe we want to get to triangle B. Maybe triangle B looks like this, and maybe triangle A looks like this. All right? Now, how can I make this triangle exactly on top of this triangle? Okay, there's lots of ways to do it. Okay, so let's see. Maybe we could, I think maybe I would, let's rotate counterclockwise 90 degrees from where we're at right here. So we're going to stay in this quadrant. We're going to stay in quadrant 3, and let's rotate 90 degrees counterclockwise like this. Okay, there's something. Maybe now we translate up. Okay, now what do you think we can do? Well, there's 90 degrees, 60, 60, 30, 30. Here we go. We can do a reflection over the y-axis. Look what happens. When you do that, the 30's on the 30, 60 on 60, 90 on 90. Okay, so one more time. Reflect over the y, you get, they're exactly on top of each other, like that. Okay? And if they're directly on top of each other, then if they lie on one another, then you can say that they're congruent. Okay? So is triangle A congruent to triangle B? Yes. All right. That's gonna do it for this video. In the upcoming videos, I'm gonna make some practice test problems, test level problems, so that we can practice doing it on a test level. All right. Thanks for watching, guys.